We're going to review the questions from the Thanksgiving packet, so please have your red pen ready. I'd like you to follow the strategies that I use on this take-up, because I think that these are the strategies that are going to help you be successful on your future assessments. Okay, so let's get our pens out, and number one, which of the following would be found at the center of an atom? Okay, and what you should do is draw your atom and draw the things in it. Inside are Peggy and Norman, and don't forget Peggy gets a plus because she does all the work and Norman does nothing. And orbiting the atom are the children who do less than nothing, so they are negatively charged. So which of the following would be found at the center of an atom? Positively charged electrons. Well, let's look. There's a positive charge, but it's a proton, so A is incorrect. Positively charged neutrons. Well, there's a neutron, but the neutron is not charged. He does nothing, so he doesn't have a charge. Negatively charged protons. Well, it is a proton, but protons are not negatively charged. Protons are positively charged, so that makes D the correct answer. Positively charged protons. Okay, let's go on to number 2. Charlie has 2 containers on the table. One of the containers had sand and water in it, and the other container has water and milk in it. Which container could be classified as a mixture, and why? Okay, and don't forget, a mixture has 2 or more types of matter, and I just put 2 plus because that means 2 or more, and it is easily distinguished. Okay, so we have to remember that when we're deciding which one is a mixture. Okay, so let's look. We've got sand and water and milk and water. And the sand and water, sand won't dissolve in water, so you'll probably have some sand on the bottom and then you'll see some water. But if you had milk and water, it would look like the same mixture. You wouldn't be able to tell which one was milk and which one was water. So we're going to look for this one with the sand and the water because it has two or more types of matter and it's easily distinguished. Okay, so here's our choices. The sand and the water, because the components are easily distinguished. That is exactly what we just talked about here. And good test takers move on and look to make sure that there isn't a better answer. But let's go ahead and look. The milk and the water, we know that's incorrect because you can't tell the difference between the two. Even though there's 2 or more types of matter, you cannot tell the difference. The sand and water, because Charlie can't separate the sand, well, that goes against what a mixture is. As a mixture is one that we can distinguish or separate easily. The milk and the water, and that is incorrect because we know that is a solution. Okay, moving on to number 3. A substance X is a solid at 30 degrees Fahrenheit and a gas at 199 degrees Fahrenheit. At which temperature would substance X be a liquid? Now, this is the one where you just have to draw your thermometer and put your 2 spots, okay? So it's a solid at 30, okay? So put solid down here, and then it's a gas at 199. And what we know about matter is that anywhere in between, it's going to be a liquid. So what we have to do is find one of the temperatures in between 199 and 30. So 200 degrees Fahrenheit, that's not in between, that's up here. So it's a gas there. So that's not correct because we're looking for a liquid. At which temperature would it be a liquid? 86 degrees Fahrenheit, well, is 86 in between these two? Yes, it is. 86 would be in between these two. So that's good. Minus 12, that would be way down here, and that would be a solid, so that's incorrect. And 212, that'll be way up here, so that'll be a gas as well. So we found our answer B, 86 degrees Fahrenheit. Okay, number 4. In order to change the state of water from a solid to a liquid, you would need to. Okay, so when you're changing state, you need to remember, you go from a solid to a liquid to a gas, and in going from solid to liquid to gas, that requires an increase in temperature. And if you're going backwards from a gas to a liquid to a solid, that would require a decrease in temperature. This comes straight from our notes. Okay, so it says in order to change the state of water from a solid, so we're starting off here, to a liquid, so we're ending up here. So we go from 1 to 2. You would need to increase the temperature. Well, is that correct? Yes, that's our choice. Okay, let's keep looking and making sure. Decrease the temperature? No, that's incorrect. Maintain the temperature? No, because if you maintain the temperature, that would mean you would keep the temperature the same. And if you kept the temperature the same, it would remain a solid. Put the solid in the freezer? No, because if you put the solid in the freezer, it would stay a solid. Okay, so A is our correct answer. Okay, the main source of water for the water cycle, this is going back to the unit before. I always like to cycle back with a couple of important questions. Does it come from rainwater? No, because we're talking the main source. Where is most of the water on Earth? Where does it come from? So it does not come from rainwater. It does not come from rivers, even though rainwater provides water, rivers provide water. Saltwater oceans, yes, because the Earth is almost full with oceans. It's 2/3 of the Earth's surface is oceans. Groundwater, no. So oceans, and we know that oceans are made from salt water because when we go swimming, the water is salty. Okay. Substance B has molecules that are loosely associated. Okay, so let's draw our little molecules, and they're loosely associated. And it has a definite volume of 48 milliliters. Okay, so defined volume. And it takes the shape of the container. Sorry about that. It takes the shape of the container into which it's placed. So let's look. Does it have a defined shape? Okay, it does have a defined volume because it says it has 48 milliliters. But it does not have a defined shape because it says it takes the shape of the container into which it's placed. So that means it changes its shape so that the shape is not defined. What could substance possibly be identified as? Well, is it a vapor? Well, we know it's not a vapor because the molecules are loosely associated, and in vapor, molecules are scattered. And we also know that vapor is a gas, and gases do not have defined volumes. Okay? The next choice is it a pencil? And we know it's not a pencil because a pencil is a solid, and a solid has a defined shape. So no, it is not a pencil. Milk? Well, milk is a liquid, and a liquid has loosely associated particles, and it has a defined volume, but not a defined shape. So milk is a good choice because milk is a liquid. And the last one, a ruler. Once again, a ruler is a solid, so it would have to have a defined shape and volume. So C it is, milk.